Hi guys, Mr. Kane here. Good to see you again.
Hi guys, Mrs. Goswish. Mr. Kane?
Yeah?
What's on the board now?
Oh, hey, that's my new periodic table. It's magnetic. This is kind of something we do every once in a while, isn't it? We ask what's behind us.
Yes, is that?
Or you ask what's behind us.
I do, yes. Is that being slightly periodic?
I think it might be
Is that
periodic.
a pattern?
It's predictable, that's
Wow.
for sure. Today's topic is families and properties on the periodic table. So you're going to get the idea that some things are predictable, some things are going to be pattern. We're going to dive right in. So we just wanted to point out when we start out here, we're going to talk about metals, nonmetals, and metalloids. So we've got these highlighted. Notice the metalloids are all on the staircase.
There are 8 metalloids with the exception of aluminum. All of them touch the stairs, right? Okay.
The metals are all going to appear in yellow. The metalloids are all going to appear green, and the nonmetals will all appear.
Okay. Now these are the main categories of the periodic table, and then they're broken down into subcategories, right?
Which is what we're going to start talking about next.
Okay,
We'll start
sounds
with
good.
hydrogen. Oh, one more thing while you guys are looking at your periodic table here. So we're gonna add a couple things here. Common charges of ions. Okay, now this isn't the charge of the atom, which a lot of people think, but it's the charge of the ions. So this group, the first group, usually has a charge of 1+.
That means it lost an electron and lost 1 electron.
Okay. The second group has a charge of 2+ commonly.
Meaning that it lost electrons and it lost 2 of them.
Mm-hmm. Now, we're going to skip all these guys in the middle, the transition metals, but when we get to group 13, we find that it is 3+.
3+, so it lost electrons, 3 of them.
Mm-hmm.
Okay.
So with the fourth group actually has 2 ways to go. It could be plus or it could be minus.
With the exception of tin and lead.
Okay,
correct?
with the exception of tin and lead. These are exceptions here.
So the
Okay.
carbon, silicon, and germanium could gain or lose 4 electrons.
Mm-hmm. Now, here's where it gets a little funky. It starts going down. Nitrogen's group can be 3-.
Okay, so it gained 3 electrons.
Gains 3 electrons. Oxygen's group is 2-.
Gained 2 electrons.
And fluorine's group is 1-.
All right.
Helium's group here, no charge.
No charge. Okay, they don't form charges.
They do not form charges. Okay. All right, let's get into it. We'll start talking with hydrogen.
All right, sounds good.
We got hydrogen here,
Okay.
which, Mrs. G, this is the only element, I think, that is its own family.
Yes, because it's not part of family number 1, which includes the lithium, sodium, potassium guy. He is kind of an extraordinary element, Mr. Kane. He kind of has his own properties, his own everything. Chapter.
All right, let's run through a few of the properties here. Has a it says here represented by the symbol H in the electron configuration 1s1, which that's kind of a preview. I think we're going to learn about that later.
Okay, so energy levels, right?
Yeah,
so
energy
first
levels.
energy level, and there's only 1 electron.
First energy level, 1 electron, but we'll get to that before Christmas, I hope. Hydrogen's colorless, odorless, and tasteless. Tells bad jokes, awful jokes. Forms elements with more compounds than any other elements, and that's probably because it's the most abundant element in the universe.
Oh, and is it a colorless, odorless, tasteless gas in its element form, correct?
In its elemental form, yes.
Okay, but then it can form other compounds that aren't necessarily gases, right?
Right, like for instance sugar, C6H12O6.
Okay.
C6H12O6. It's got 12 hydrogen atoms, and that's sweet stuff.
Okay, and that's a solid. Or water,
Yeah,
liquid
H2O.
water at room temperature.
Mm-hmm. And that supposedly has no taste, although around here,
All right.
you know, be
yeah.
careful of water.
Lockport, yeah.
But that's the idea, and it's the most abundant element in the universe. If you doubt me, check out what stars are made of.
Oh, okay.
Okay. Other things about hydrogen, there's very little of it free in the Earth's atmosphere because every time you get hydrogen gas, it's less dense than the air around it, and it goes up.
Okay.
Up. The Hindenburg learned about that one.
Yeah, the hard way.
All right, and then the other thing about that the Hindenburg learned is it's flammable.
Very flammable.
Extremely flammable.
Ooh, it's one of the diatomics.
Yep, one of the diatomics. It's almost like this is repetitious, you know. Science is repetitious. We've talked about that before. And it's got the lowest density. Okay.
Alkali metals. Lithium, sodium, potassium, rubidium, cesium, and francium. This is the group 1 or family 1, group or family interchangeable terms. This is group 1. Notice that hydrogen is not considered an alkali metal, even though it's on top of lithium on the periodic table. It is not an alkali metal. They do not occur in nature as elements. Usually it's a compound, a white salt compound.
Yeah, white salts. Okay.
And they're very reactive with water, huh?
Yeah, extremely explosively reactive.
Oh,
Yeah,
good.
Actually, I guess I should say violently reactive with water.
Oh.
Yeah, yeah.
Well, then they'd have to be careful just being exposed to the air, because there's water in the air, isn't there?
Exactly. Usually, if you find these in a chem lab, you find them under oil because the oil doesn't allow any water in it.
Okay.
And the interesting thing is if you put lithium in water, you get a little fizzle. You put sodium in, it's a little bit more. Potassium gives you a nice pop. And by the time you get down to the bottom,
Which is francium,
which is francium and cesium and rubidium for that matter, you're talking about some pretty violent reactions happening.
So there's a pattern there. Reactivity increases as you go down that family.
There is a pattern there, and that is a periodic pattern. Reactivity increases as we go down. So the reactivity increases as you go down the list here.
Okay.
Okay. All of these, another thing to note, they all have one valence electron. By the way, guys, if you haven't taken out your periodic table yet, I would, and I'd write this fact down about valence electrons because that's something that's periodic.
So valence electrons are the electrons in the outermost energy level,
Right.
and everything in group 1 has one valence electron. Oh, I don't know. That's confusing.
That's I could never remember that. One valence electron for all the group 1 metals. The alkali metals, I'll never remember that.
And one word, alkali. Ooh, okay.
Oh, hey, yeah, it'd be nice if group 2 had 2 words for its name. Yeah,
2 words for its name.
Okay.
Ooh.
Okay. So just to continue here, alkali metals, just like most metals, they're good conductors of heat and good conductors of electricity. They're ductile, which means that you can pull them out into wires. They're malleable, which means you can flatten them out into sheets.
And kind of move them around, right? Isn't that what we did with the magnesium ribbon?
We did that with
They're
the
kind of
magnesium.
flexible-ish?
Yeah, flexible. Here we go. That's flexible.
Okay.
These are a little bit different than most metals we're familiar with because you can actually cut these with a butter knife.
Oh, wow.
Okay, it says a knife there, but butter knife is actually what it should say because they're extremely soft. They have a silvery luster. They have low densities and low melting points. Matter of fact, lithium is the lowest density metal, and if it weren't actually reactive with water, it would float on water.
Oh, okay.
But since it reacts with water, it
kind of goes pop.
kind of goes pop.
And low melting points. Okay.
Low melting points, yeah, and that goes along with the softness.
Ooh, group 2, alkaline earth metals. Oh, look, there are 2 names in group 2.
Oh, hey, that's nice, alkaline and earth. So there are group 2 names. I wonder how many valence electrons.
Ooh, wait, let me think. I'll bet there's 2.
It should be writing that down at the top of group 2 on your periodic table. All right, so beryllium, magnesium, calcium, strontium, barium, and radium.
We just listened to the element song. Can you sing that? No, I'm kidding. Don't do it. They do not occur naturally in their elemental state. Again, usually as salt, which means a compound, right?
Correct. And the part that I like about this, they're colorful salts. If you actually want to see what a colorful salt looks like, go to Wikipedia and look up magnesium salts or calcium salt or strontium salts. They got pictures on there. They're actually pretty salts.
They're less reactive than the alkali metals. Okay. They are also good conductors of heat and electricity. They are also ductile and malleable and have a silvery luster.
And the thing about these, they're not quite as soft as the alkali metals. Remember, we dealt with magnesium in class, and we kind of got to bend it a little bit. It bends, but it doesn't really cut with a knife.
Okay.
Okay.
Yeah, that's true. Yeah, we burnt that. That's the one we burnt with the big bright light, right?
Yeah, that's right. And this is kind of a pattern. So on the left, you got soft. To the right of the left, you've got a little bit less soft.
Yeah.
And transition metals are even less soft.
Okay.
They're harder metals. Okay. Now, the groups 3 through 12 transition metals, they don't follow the periodic trends as well as we'd like them to, but they do consist of metals.
Okay.
They do contain 1 or 2 valence electrons usually, although as we get into the deeper chemistry later in the year, we'll talk more deeply about why we say usually, and we're kind of hedging here.
So transition metals typically have more than one potential charge.
Yeah, that's another thing is that, yeah. Mm-hmm.
Usually harder and more brittle. Well, that makes sense. I mean, I'm looking at I see copper, I see zinc, iron. That would definitely be harder than a sodium.
And they've got higher melting points and higher boiling points than the metals.
Okay. One little issue with your periodic table, if you wouldn't mind, Mr. Kane. The germanium, antimony, and polonium.
Ooh.
Those are not transition metals, so let's cross
That's
those
right.
out real quick.
I'm going to fix that up here. Notice, guys, these guys are next to the staircase. They are technically not metals, so we can't count them as transition
Yeah, they're
metals.
metalloids, semi-metals.
One transition metal, though, that we should have included, and it's just in the picture here,
The aluminum, isn't
is
it?
aluminum. So you might want to just make a note that aluminum is a transition metal, but germanium, antimony, and what was this? Polonium. And
Well, I can't see
septinium.
that. Okay.
Element number 117 are not transition metals.
Malleable and ductile.
They're also malleable and
okay.
ductile, and we should know that. We've seen
Aluminum
check this out.
foil.
I mean, iron, nickel, copper, aluminum, gold, silver. Most of the metals that we see in our everyday lives, like platinum. So they're all metals we're familiar with. And notice also, there's two metals that don't have a silvery luster.
Okay, copper and gold. That
Copper
makes
and
sense.
gold. And we're familiar with both of
Yeah.
those. One of those is my favorite, and the other one is the one that I have a lot of.
Yeah, I understand that.
So the inner transition metals, as they're called, maybe I should give the generic name first. Inner transition metals. There are actually two groups that are horizontal that we talk about as groups, but usually we talk about groups vertically.
That's true.
But these are called the lanthanides and the actinides, or the actinides, depending on who you are and where you're from. The lanthanides, you can see, start with
Lanthanum. That's
and the
hard.
actinides, or the actinides, as I call them, start with actinium.
So these are the two rows that are always under the periodic table on any book or on our wall, correct?
Mm-hmm. And they only put them on the outside. They only put them on the bottom because they don't actually fit very well where they're supposed to go. On the periodic table handout we've got, there's a little gap where they're supposed to go. It says,
Yeah.
it actually says elements 57 through 71 fit here. They don't fit there because of the way printing goes.
Okay, yeah, because your book would be awfully tall if we had to put that in the book as is. I can understand that.
Okay, so the lanthanides, basically what you need to know is they're shiny, silvery metals, similar in reactivity to group 2.
Okay.
So they're extremely similar to the alkaline earth metals.
Right.
Two names. All right. And the actinides all wind up being radioactive.
Well, yeah, there's uranium, right?
Yeah, uranium's in there, right? So that should be an obvious for you. They're all radioactive. Only 3 of them were found on Earth. The rest of them were man-made as far as the things that on Earth.
Synthetically made.
They exist elsewhere in the universe, but not here.
That would explain why one of them is called Einsteinium. Somebody made it and called it after Einstein, huh?
Yeah, and then this one here was made at University of California, Berkeley.
Berkeley, and I see
and
Curie.
and Californium.
Okay.
Fermium, named after, Mendelevium. I wonder who that one got
gee.
named after.
That's a long stretch of the imagination, yeah?
Nobelium. They should start giving out prizes by a guy named Nobel. That would be awesome.